evening. Let's get started with question 621, task scheduler. Given a character array representing tasks CPU need to do, it contains capital letters A to Z, where different letters represent different tasks. Task could be done without the original order. Each task could be done in 1 unit of time. For each unit of time, CPU could finish one task or just be idle. So, however, there is a non-negative integer n that represents the cooldown period between two same tasks. That is, there must be at least n units of time between any two same tasks. You need to return the least number of units of times that the CPU will take to finish all the given tasks. So, example, here we have 3 A's and 3 B's, n equals to 2. So, after doing 1 A, we need to give a gap of 2 units. So, we can't do A again, so we will do B. We still have a gap of 1 unit, so we will keep it idle. Then we can do A again, then we will do B, then 1 idle unit again, then we will do A, then B. Our tasks are finished. That's our answer. So this 8 hours is our answer. So a nice way to do this problem is, first of all, extract the frequencies from the tasks and then sort them. Now we won't be needing the name of the tasks right now, so no need to store the names also. So sorting will be of no issue then. So we extract the frequencies and then sort them in this order here. Now let's iterate through this array. So first of all, we selected the task A, then we can go to task B here and then to C here, because we need to have a gap of 2 tasks between 2 simultaneous tasks A. Then we can either go task D and E and then go back to A, or we can go back to A and then go to D and E. Let's see the result in both the cases. First, let's go to D and then E. Then we go back to A here. Then we go to A again, A. Now in these 3 A's here, after we reach A, we have to give a gap of 2 units as we don't have any more tasks. It will be idle. Same for this A and this A. This will be the last A, so we don't need to give any more idle units to this A. So these 3 A here will each receive 2 idle units. So the total number of idle units will be 2 into 3, that is 6. And the total number of tasks were 5 into 5 plus 4, that is 9, plus 6, that will be 15. So the answer here would be 15 cycles. But let's see what would happen if we did this instead. From C, we would go to A, and then through D, and then to E, and then to A again, then to A again, then to A again. In this case, we only need to give these 2 A's 2 idle units, as after going from C to this A, we still have 2 tasks remaining. So in that 2 idle task slot, we can insert D and E task and then come back to A, then A. As these are simultaneous A's, we will need to give a gap of 2 idle units in this A and this A. This will be our final A, so no need to give any idle gaps after this. So for these 2 A's, it will be 2 into 2, that is 4 idle units. Total number of tasks are 9. 9 plus 4 is 13. So in this way, we got our optimal answer. So how does sorting actually help here? Well, we will sort this as 5, 1, 1, 1, 1. Then we subtract 1 from each of them as we progress through tasks. So this 5 would become 4, 1 would become 0, 0, 0 and 0 will get eliminated. So we have 5, this 4, 0, 0, 1, 1. So we will again sort it. Sorting will give us 4, 1, 1. Then we can again start from 4 to 1 to 1. So in this way, we will be getting our optimal answer. For more insight, let's see this example. First, we have 4 here. So when we do this first task, our answer would reduce to 3. This 3 would become 2 and this 3 again would become 2. Because n is equal to 2 here, we only need 2 tasks to fill in the idle gaps. So if we don't sort it, So we come back to first again, as we have to start from first each time we start assigning the tasks. So we again reduce it to 2, we reduce it to 1, and we reduce it to 1. So if you see this carefully, after this next task, what will happen, that this will be reduced to 1, 0 and 0. Then this task is 1 here, and we have task A, D and E. B and C have become 0. So we complete A, then C, then E, A, then E, then E. Now we are left with 2D tasks. So between the 2D tasks, we will have to give a gap of 2 idle slots because the tasks are same. So the resulting answer would be total task plus 2 idle slots. So what if we sorted this array previously? So let's go to our original test case, that was 4, 3, 3. Then 4 was reduced to 3, 3 to 2, 3 to 2. Now we will sort this, so we will get the 3 here and 2 here. This would be the sorted order. Then we again iterate through the tasks, so this will be reduced to 2, to 2 and to 1. Again sorted, this will be the order, sorted order. Now actually these tasks are like move forward and backward, so I've lost the track which was A and C. So we won't need the names, we just need to calculate the resultant number of cycles. So now we have 2, 2, 2, 1, 1. So now this is really simple. We can just do this task first, then this task, then this task. So this will be 1 and 1 and 1, and then again this will be done, this will be done, this will be done. So it would become 0 and then this and this. So we don't actually need any idle cycles here. So in the previous case when we did not sort, we needed 2 idle cycles, but here we don't need any idle cycle. So this is actually our idle answer, as this requires the minimum number of cycles. So that's all with this approach, and I hope that you can code it yourself. And if you have any problems, we can provide the code to this approach also. So we will be seeing a different approach now, that is, why don't we just calculate the number of idle slots that we will be having in the last, and then sum it up with the total number of tasks we have. That way we will get the resultant number of cycles. Let's see how. First of all, we need to calculate the maximum number of idle slots that is possible. So what will be the maximum number of idle slots? First of all, we extract the frequency, sort the array and those things. Then we take the maximum frequency here and then fill this in this table. Now after filling this in this table, we know that this after we completing this task A, the last of the task A here, we won't have any more tasks remaining. If you are confused with this 4 here again, we will see that later, but we won't have any more tasks after completing the task with maximum frequency. So we don't need to allot any more idle slots here. We just need to allot the idle slots till 2 tasks A were remaining, and this A task was completed and 1 task A is remaining, and here we need to allot idle slots in order to get to task A. So we need to assign the idle slots till maximum frequency minus 1 rows. So this is the maximum frequency, that is 4, minus 1 is 3. So we need to assign task till first 3 rows, and then the number of initially idle slots would be equal to this number of rows here and this number of columns. So what will be the columns? Well, it would be the gaps here, that is between 2 task A's we need to give a gap of 4 units. So 4 idle cycles here, so 1, 2, 3 and 4. So this gap multiplied by this number of rows in which we need to assign the idle cycles. So this will be the maximum number of idle cycles that will be possible in a task scheduler. So we will calculate it as 4 into maximum frequency minus 1, that is 3. So it will be equal to 4 3s are 12. Yeah, we have the maximum number of idle cycles. Now what is this max V? this max v will be the maximum frequency minus 1. Why we will be using it, we will see later. So we will store this as 4 minus 1, that is equal to 3. Okay. Now we have the values that we need. Now we will iterate through the remaining values and fill this table here of idle tasks. Why are we filling this? Well, we don't want these idle slots to remain idle. We can fill them with tasks instead. So we will be filling those tasks in columns, not rows. Why not rows? Well, in that way we won't have the desired gap. That is, if we fill, suppose the first task was A, then this is B, C, D and E. We are assuming. So we can fill this B here in these, but not B and B, because this condition here of gap equal to 4 won't be satisfied. So when we fill B in the columns, it will be like this. So B here also, B here also, and B here also. So in this way, 1, 2, 3 and 4, there is a gap of 4 between two B's here. So our condition is also satisfied and the idle slots are also filled. Now what will we be subtracting from the total number of idle slots? Well, you can see here we'll be subtracting 3, not 4. Why? Because this here was not actually an idle slot. So that's why we stored the max v here. This will store the maximum rows which will have idle slots, and this is the frequency, the current frequency on which we are on. So first of all, we won't include this max frequency as we have already accounted it as A's frequency. We are on this frequency here 4. So after seeing this 4, we will be taking minimum of the current frequency and max v. Why minimum? Well, if we fill this 4 slots here, as this frequency here won't be greater than the maximum frequency, because maximum frequency is maximum, nothing is greater than that. So this 4 here will be maybe equal to the maximum frequency. So this 4 here will be 1 plus max v, that is total number of rows in which there are idle slots. So we'll be taking the minimum of that, because we are subtracting the tasks which fill those idle slots, not the total number of tasks. So the tasks that fill those idle slots are these 3 B's here. So we'll be subtracting minimum of max v and 4, that will be 3, minimum will be 3. So let's update this idle as 12 minus 3 is 9. Now we have 9 idle slots here. Now we fill in 2. We'll be storing again, we're subtracting the minimum of max v and 2. Why? Now we have less frequency, that is 2 here. So C can be filled here and here. So there is still one idle slot remaining here. So we have to store the minimum of max v, that is 3 here. We can maximum fill these 3 idle slots, or we can fill the idle slots according to this frequency 2. So as we have only 2 C's, we can fill these 2 positions. So we have C's, and then similarly fill this 2 D's and then 1 E. So E will be here. So first of all, we stored B. So the answer was 12 minus 3, that is 9. Now the answer was 12 minus 2, that was 7. Then D, so 5, and then E, so 4. So as you can see, this idle slot 4 matches our answer here. We have 4 idle slots, and the total number of tasks have also been filled with maximum gap. That is, there is at least a gap of 4 units between 2 same tasks. So we have satisfied these conditions. Now what if we had this condition here? We will see only one more example. So let's fill the table here. We have already filled A's, and assume that this is B here. So we will again have an idle slot of 3 here, because we have n equal to 1, that is, we only need to have a gap of 1 task, and the maximum frequency is 4 here. So we will be filling this task B here. So remember that the total number of idle slots was equal to 3. So filling these 3 B's here, we will be filling B and B and B. Oh, now we don't have any idle slot. So where are we going to fill these 2's? Well, this 2 can either go here, that is 2 is C actually. This was A and B and C. So this C can actually go to either this side or this side or this side. Actually it won't matter because this isn't increasing the number of idle slots. Well, we won't be filling these C's. Yeah, we won't be filling this C here and here because in this way the gap would be 0. So we need to have a minimum gap of 1. So if we like leave a gap here and then fill the C here, so that won't be our optimal answer because the gap here is 1. But we can get a gap of 0. How? We can just fill the C either here or here, or we can fill the C here and here. So we are getting a gap of 0. So we will always be getting optimal answers through this approach. So in this approach, basically what you have to do is extract the frequency and order them in descending or ascending order. Take the maximum frequency, find the maximum number of idle slots, that will be equal to maximum frequency minus 1 multiplied by the gap. So we will have the idle slots, that is 12 here, and then start filling in the remaining number of tasks. So we will be filling, subtracting only those values from idle total number of idle slots which will be filling these idle slots. So as B was coming 4 times here, but only 3 B's were filling this idle slots. We will subtract 3 from total, that is 12. Then we will again subtract 2 C's, then 2 D's, then E's, and then at the end we will get the remaining idle slots. Similarly here we won't have any idle slots, so the idle slots would be equal to, here the idle slots would be actually be equal to minus 2, because first we have 3 idle slots, we subtract 3 from it, that is B, and then we again subtract 2 from it because there are 2 C's. So the idle slots would be minus 2, but we can't have idle slots in negative. So what we will actually be storing is that if idle slots is equal to 0 or negative, the effective number of idle slots would be 0. That is, we don't even need idle slots to do those processes. So that's it, that's the approach, and now let's code it. So first of all, we have this task array here and the size is 26. Why? Well, we have the task from letters capital A to Z. So we have 26 alphabets. So for storing those frequencies, we can only have 26 types of tasks. So we can store those 26 types of tasks in this array. So this is just initializing the array with 0. And this is a for each loop which will iterate through each character in this tasks array. Now there's a difference between this task and this task. This task array will contain these tasks, that is A, B, 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 and this task array here, task array will store the frequencies of those A's. Like this here will store at index 0 it will store 3, and at index 1 it will store 3, and rest of the indices it will store 0. So we will be storing the frequency here, and then as I said, we will sort it. Sorting it in ascending order first. So in the whiteboard you saw that I sorted it in descending order, but here I will be sorting it in ascending order. So what I will be doing is to extract the maximum, that is the maximum frequency of the task. I will be taking the last element, as we have indexing from 0. So in an array of size 26, the last element is task of 25. So max V will be equal to task of 25 minus 1. So as previously said here, it would be 4 minus 1, that is 3, max V would be 3 here. And then to find the maximum number of idle slots that we can have, we will be multiplying max V, that is 3, with n, that is the gap we need to give between two same tasks. Then we move ahead with the for loop, and you can see here we will be iterating this for loop from 24 to 0. We won't be taking in account this index 25 because we have already accounted for it, because this table here, this index, maximum index here, maximum frequency here is already accounted for. So we'll be seeing this frequency from the second last, that is the second maximum element. So the second maximum element, which may be same as maximum or less than maximum, would be in index 24. So as index 25 is already accounted for, we will be iterating from index 24 onwards till the last index, that is 0. And then here it is idle equals idle minus minimum of max v and task I. That as I explained before, this max v will store the maximum number of idle slots that a task can take. The task cannot take more slots than max v, and this task I will contain the frequency of the task. So either the frequency of the task is less than or equal to max v, or if the frequency is greater, as a task can only take max v number of slots, we will subtract max v. Else, if the frequency is lesser, that is if the frequency is 2 here, we will subtract 2 from the total number of tasks here, that is idle here. So idle minus minimum of max v, that is the maximum number of slots that can be allotted to task, or the frequency of the task itself, which is less than max v. So subtracting this, we will get some idle. So here we were getting a positive answer for idle, that is 4, but here we would be getting a negative answer, that is 3 minus 3 is 0, and then 0 minus 2, that would be minus 2. So if idle is negative, then we set idle to 0, because we can't have those idle slots in negative. It's not possible. That just means that we don't even need idle slots to complete all these tasks. So after allotting this 0 to idle, if idle is less than 0, we will just return our answer, that will be task size plus idle. So if idle is positive, that is we need some idle slots, so we will add them to the total task we have, and that would be our answer. Else if idle was 0 or negative, we won't be needing any idle slots. So we will just return the number of tasks that we originally received. The CPU will complete them as it is, and then that's it, the process is completed. So this is your solution. And if you have problem coding the naive approach, as I said before, that is sorting again and again, you can contact us and we can also give the solution to that approach. And that's it. Hope you understood the solution.